change in momentum. Clear? Hello?
Yes, sir.
Yes, sir.
Okay. Please let me know if you are not clear with this, because this is very important. This is first statement of Newton's second law. Right? So, अगर नहीं समझा, please let me know. I'll explain again with some other examples, some different examples. But it is important for you to understand that force changes momentum, and change in momentum produced by a force is directly proportional to force. Double is force, double is change in momentum. Half is force, half is change in momentum. Triple is force, triple is change in momentum. Okay? Now, question is time of impact. That is time for which force acts on an object. Is this significant? Is significant or not? Question is time of impact. That is time for which force acts on any object is significant or not. Like if you double the force, change in momentum gets doubled. If you halve the force, change in momentum gets halved. The question is whether there is any role of time of
Yes,
impact.
sir. Yes, sir.
Okay.
Because
What is role
velocity is
of
velocity also has times. Velocity is also has time. So like time is related to force.
No, that time has nothing to do with this time. That time is something distance traveled per unit time, right? A displacement per unit time. That time is different. It has nothing to do with the time of impact which I'm using, which I'm discussing here. Then anyone? Time for which force is applied is significant or not? Yes, it is significant.
So your mic is mute.
So,
Sir,
It is significant.
why it is significant?
I'll explain. Because if you apply the same force for more time, change in momentum will be more. Na? See, this is an object. Okay? I started pushing it with a force of 100 Newton. Naturally, its speed will start moving, and its speed will start increasing. Right? Say at the end of 5 seconds, if I leave this object, then will its speed increase further?
no, sir.
Will its momentum change further? No. But if I continue applying the same force for more time, for 10 seconds, do you think change in momentum this time would be more?
So it will increase if you increase your force.
No, forget about force. See, three things are used here. Force word I'm using, change in momentum I'm using here, and time of impact I'm using here. I'm using 3 words here, right? I'm using 3 words. Force, momentum, and time of impact. I'm using force, I'm using momentum, I'm using time of impact. I'm using these 3 words, right? So forget about force. I'm not increasing force. I'm increasing the time for which it is applied. So don't you think it will produce more change in momentum? Okay, leave it.
Sir, it
come with
could be
another
because
example.
acceleration is v minus u by t, so that t could, if it's different, so the whole force will be different.
It is true. This time you're correct, but I'll come to it later. This T I have to understand or make you understand from other angle. I'll show you. Suppose there's a bus. Suppose there's a bus which is moving with say 20 meter per second. See, there is no friction, no other force to stop. You alone are given a rope and tied a rope to this, and I asked someone, you are asked to stop this bus alone. Can you stop this bus alone?
No, sir.
Sure,
Yes, sir. Sure.
you can. Even a force of very small magnitude can stop this bus. My statement is, believe in yourself, you can stop this bus all alone. Even if there was you are alone, there is no friend from your side or any machine or anything to help you. You all alone can stop this bus, right? Okay. I'll not explain it further. I'll take another example. There's another example in which the same bus is there. This time it is moving 20 meter per second. And you have 10 of your friends who will help you stop this bus.
Yes, sir. We
10
can
of
stop
friends.
it.
So 10 of you can stop, right? Trust me, you alone can also stop the bus, right? And 10 of you can also stop the bus. Let's figure out the differences in the two cases. You alone are applying force, here 10 people together are applying force. In which case force is more?
In second.
In second case, force is more. Force is more. This bus was moving at 20 meter per second, comes to rest. So what is change in momentum? Suppose this bus is of 200 kg. So what is change in momentum? Anyone? That's why I made you practice so many questions based on change in momentum. See, bus of 200 kg is moving at 20 meter per second. So what is momentum? 20 into 200, that is 4,000.
The 4,000.
And finally it comes to this.
Negative
So change in momentum
4,000.
is 4,000 minus 4,000
Yeah, for
kg.
fourth.
What is change in momentum in this case? It is again minus 4,000 kg meter per second. Right? Change in momentum is same in both the cases. Force is less in this case. Force is more in this case. Think the two cases will differ in one more point. What is that point? You have to think and answer. The two cases will have one more thing different. They have same change in momentum. Forces are different. In the second case, force is more. First case, force is less. They will differ in one more thing. What is that thing?
How much time it takes to stop the bus?
How much time it takes to stop the bus? In which case time is more or in which case time is less?
In the first
So in
game,
first
time will
one,
be more, and the second case, time will be
second
less.
time will be less.
Here time is more. Time is more. And in this case, time is less. That means time has something to do. And this comes from your instincts. You don't look, even if you don't know the theory, then also you can think and say. If you want to bring same change in momentum, then if you apply more force, then the same change in momentum can be brought in lesser time. No. Suppose, if you recall, I've given you an example, performing in exam, performance in exam. If you have to score 90 plus 90, let us say. If you are more intelligent, that means you can exert more force, then even if you study for lesser time, you can achieve this. Right? So time is important. Maybe this was not a very good example, but it is. relates the two cases. Let us take it directly. So here force, more force is applied. More people together were applying force, so they could apply more force. Change in momentum brought down in the two cases was same. Here also minus 4000 kg meter per second. Here also it is minus 4000 kg meter per second. But in this case, force was more. So the same job is done in lesser time. Time taken is less. So same job is done in lesser time. Whereas in first case, the same job is done in more time. So believe me, even you alone can stop the bus. Yes, it will take more time. Maybe before it comes to rest, it has covered a distance of 200 meter. You were applying force, you were giving some, offering some resistance, but it went up to 200 meters before it comes to rest. Or it took almost 15 minutes or 5 minutes for you to stop this bus. But in this case, maybe the bus will come to rest very soon. Right? It takes lesser time. So this is another point in Newton's law of motion. So answer to this question is force is inversely proportional. It's a very important point. Inversely proportional to time of impact. Force is inversely proportional to time of impact. As force was directly proportional to change in momentum, it is inversely proportional to time of impact. I'll write an example and then I'll club the two statements to conclude Newton's first law, second law of motion. Suppose there's an object, there's one more object, some force X on this object, same force X on this object. Both of them see same change in momentum. Same change in momentum. Same change in momentum. Right? If time of impact is doubled, in this case, force needed is half. If two bodies are acted upon by two forces, not same forces, two forces, both of them see same change in momentum. So if time of impact was more, if more time took in this case, then actually you would have applied half the force. Double the time of impact, lesser was the force activated. If you apply triple force, 3 times of F, then time of impact needed to produce same change in momentum would be 1/3. To produce same change in momentum, if you double the force, then time of impact, the time needed to bring that change is halved. If you triple the force, then time needed to bring that change becomes 1/3. If you make or increase the force 5 times, then time needed to bring that change will reduce by 5 times. Okay. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Prisha बोल रहे से कुछ भी नहीं बोल रहे.
Yes, sir.
आ रहा समझ में?
Yes, sir.
Okay. ठीक है. So let me club the statements now. So earlier I said force is directly proportional to change in momentum. Then I said force is inversely proportional to time of impact. Now this is Newton's second law of motion. Force acting on any object is directly proportional to rate of change of momentum with respect to time. मतलब if at time t1 and t2, if momentum was p1 and p2, momentum is p1 and p2, then what is change in momentum? P2 minus P1, and time of impact T2 minus T1. I'll repeat. There is an object which is acted upon by some force F. At time T1, its momentum was P1. It changes at T equals to T2, momentum changes to P is equal to P2. So what is change in momentum? P2 minus P. So applied force is directly proportional to this and inversely proportional to T2 minus T. Proportionality constant in this case is 1. So actually it is equal to P2 minus P1 on T2 minus T. Force is equal to rate of change of momentum with respect to time. This is Newton's second law of momentum. P2 minus P, this is force. F here stands for applied force. P2 minus P1 is change in momentum. Change in momentum. And T2 minus T1 is time interval. So force is measured as change in momentum per unit time. Trust me, this is very interesting law. This gives quantitative definition or idea of force. How much force will do what in how much time. So the statement is force is directly proportional to change in momentum and inversely proportional to time of impact. More is force, more will be change in momentum, and if change in momentum is same, then lesser will be time taken. So there is an exact equality. In fact, this becomes the formula for measuring force. In motion, force is measured as change in momentum per unit time. Right? I'll write 2-3 questions for you to adapt to this formula. I'll write a question. Momentum of an object. Momentum of an object changes from 15 kg meter per second to 29 kg meter per second due to action of force, some force in 2 seconds. Calculate the magnitude of force. No. Momentum of an object changes from 15 kg meter per second to 29 kg meter per second due to action of some force in 2 seconds. Calculate the magnitude of force. Sarvesh, your class will start in 10 minutes. Huh? So my aim is to make you adapt to this formula or definition or Newton's second law of motion, which says force is equal to rate of change of momentum with respect to time. Hello.
40.
14 Newton is answer. Let's see how. See, force is change in momentum. Right? change in momentum upon time of impact. That is time for which the force acts. So here momentum changes from 15 to 29. So what is change in momentum? Change in momentum is 29 minus 15. So change in momentum is 29 minus 15 upon time. So time of impact is 2 seconds. So 14 upon 2, that is 7 Newton. So the force acting on it is 7 Newton. वापस बोलूं?
No.
Sachit,
Yes, sir.
it's clear or I'll explain again?
Sir, I guess it will be better if you explain it again.
Okay. I'll ask another question then. Let me write another question. So next question is, an object experiences a force 20 Newton for 15 seconds. If its initial momentum was 0, yes, not 0, 20 kg meter per second. Find final momentum. That is momentum after 15 seconds. Find final momentum. An object is acted upon by a force of 20 Newton. There is an object which experiences a force of 20 Newton, and that force acts for 15 seconds. If its initial momentum was 20 kg meter per second, find its final momentum.
Sir, 15.
So I'm saying it's 15.
50 is not the correct answer.
15, 1, 5.
Sir, 15.
It's very important for you to understand this formula. This formula helps us relate force with change in momentum. See, force is what? Force is change in momentum, final momentum minus initial upon time interval, right? They say force of 20 Newton acts for some time. You have to find final momentum, that is P2 is not known, P1. Momentum before the force starts acting is 20. Time of impact, it acts for 15 seconds. So take it on this side, 20 into 15, that is 300. P2 minus 20. So P2 is equal to 320 kg meter per second. That's it. So P2 is 320 kg meter per second.
So 20 kg meter per second was initial momentum, right?
Initial momentum, right?
Okay, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So I'll stop here. I have another class. Huh?
Okay, sir.
Okay. So I'll stop here.
Thank you, sir.
Okay.
Thank you, sir. Bye, sir.